Hi, Chris here with Mr. IoT. Last couple weeks I was talking with Brian over at Influx and he got me turned on to Influx a little bit. So I want to make a short video about how simple it is to get data from a Fanuc controller into the Influx database. To get started, the documentation is here at docs.ladder99.com. You scroll down to Fanuc and you end up at this page here. So we're going to skip down to the Docker installation. So what I've done here is spun up a Ubuntu server, and I could show you one CPU, 2 gigs of RAM. That's it, right? So ran through these commands. I installed Docker and Docker Compose. Right? Docker Compose lets you basically have a configuration file for multiple containers, different profiles, right? A little easier management than using the CLI of Docker all the time. In this video, we're just gonna use one of the pre-built images. I built one yesterday, I believe, and those can be found on hub.docker.com. If you search for Fanuc-Driver, it's the first thing that comes up. So right now we're building separate images for AMD 64 and ARM. In the future, we'll have a single build, that'll build cross-platform. And right now, you can see that kind of the latest, right? What I would call the latest images are off the main branch in the source code, and the most recent ones are off the develop branch. So I've been calling them with the OS architecture, develop branch, and the commit hash on GitHub. And we're going to merge these back into the main branch soon. So what we want to do is we want to use this guy here. And let me show you some of the steps you have to go through. So the first thing is to create an environment variable called focus_tgt for target, and put the tag of the Docker image you want here. This variable is going to be used inside the Docker Compose to pull the correct image down. Let's do that quickly. Export focus_tgt equals whatever we copied. We're on Linux. Yep. Okay. Right. So if you look at your exported variables, your guy is right here. All right. Cool. Next thing, where am I? All right. Next thing, we're going to work out of the home directory and create a Fanuc folder and then clone the repository. So copying these guys in at the home folder, and we're going to pull this in. So the reason why we're pulling the repository is because it has all the configuration files, some example files that we're going to use to put in our Docker volumes. And because this is, we're working off the develop branch, we have to go into the Fanuc-Driver folder, git, checkout, develop, and cd base driver, which is a submodule inside the Fanuc driver, and also git checkout develop. Yep. All right, cool. So now what we're going to do is prepare the volumes, and we're going to make a couple folders. Make one for the Fanuc driver nlog configuration. Make one for the configuration example, where the machines that you want to connect to and the destination of the data is. Then for this example, we're not going to be using Mosquito, so we can skip this section. We're not going to be doing empty connect. We can skip this section. So really what we want to do is go into these guys, copy them, create those folders, and copy things over. Before we move on, let's take a look at what these files actually look like. So now they've been copied to volumes. What's in here? Okay. All right, cool. So we have the nlog file. If we take a look at that. Okay, this defines where in the container where the log is going to get written to, right? So this is fine. And then also the verbosity of the logging. We could turn that up to debug, let's say. Save it. Now let's go through the config. So I'm not going to explain the entire configuration. Essentially, the default influx transformers leaf here defines how we're going to transform the Fanuc data and format it into line protocol to send over to influx. If we go all the way down, we have several machines configured under the machines node here. So all of them are disabled. If the machine disabled is not commented, then they're disabled. So we're going to uncomment the MQTT example. We're going to comment it. We're going to uncomment the influx example. So basically the way this is going to work is the machine identifier, we're calling it here example-influx. It's going to contain the machine base configuration. It's going to be enabled. It is going to pull data, Fanuc data from source 1, which we'll look at in a minute. It's going to use collector-1, which is a set of collectors for which data to actually pull from the Fanuc controller. The target influx instance, and change filter, which means that the data is only going to get output when it changes. Let's disable this guy. And I think the other ones are disabled. All right. So if we go up to, I don't know how to page up in Nano. Whatever. Here. All right. So here's our target influx 1. It's pre-configured with a default token. It's going to call into the influx container. All right. So this is going to run in Docker. The Fanuc-Driver container is going to call directly by the container name, which becomes addressable in Docker. Port 886, so this is influx version 2. The organization, we're going to have Fanuc, the bucket Fanuc. And then if we go find source 1 for our machine, it is here. We're going to basically sweep the controller every second at this IP address, this port, and the timeout for the focus libraries, which you need to set this above 0. If you set it to 0, that is a infinite timeout and things do not work properly. Okay, so we identified the IP of the machine we're going to send, collect data from, and we then, what do we do? Got our influx instance configuration set up and enabled the correct machine. So we can save this guy. All right, now let's see what the next step is. Oh, okay. So here is where, let's go into this folder and let's see what's in there. This is Fanuc-Driver. Okay. So in the examples folder, we have a bunch of predefined configurations. We also have the compose.yaml. Let's take a look at the compose. So the bunch of services are defined. Portainer, which lets you manage containers, and it's split into profiles. So with Docker Compose, I can call out a profile that I want to spin up, and it'll stand up all of those containers, tear them down, whatever. So we're going to do Portainer, we're going to do Dazzle. Dazzle's a nice web interface to look at Docker logs. And then what are we going to do? Influx, right? So we're going to be calling out the influx. Profile. And here's where we've defined our initialization mode for influx, which is set up with a bunch of different variables. The data is going to get retained for 140 hours. The volume of the data maps into our host, and the maximum size of log file is 20 megabytes. Right? You know, with Docker, if you don't set a maximum size, but you call out a logging driver, you'll run out of disk eventually. All right, we're going to skip the empty connect agent. We're not doing that. We're not doing the mosquito. And then Fanuc-Driver. And right here is the focus underscore TGT variable that's called out. And also its internal etc Fanuc folder is pointing to the volumes folder, or the host folder where we actually just modified the configuration for logging and the driver's configuration. So no need to save anything here. All right. And Docker Compose, okay, right. So we're gonna let's first stand up the uh, administration containers, which is the Dazzle and the Portainer. So we're gonna do profile admin, and then when we call this guy out, it's gonna pull Portainer and Dazzle. All right, so this is a quicker way to um, spin up multiple containers. Then we're going to do create, and then we're going to do start. And then, right, so these guys are starting up. Now, if you want to stop and remove them, right, there's a stop, and then there's a remove, and then you could do your Docker system prune to get rid of all the dangling artifacts. All right, so these guys are started, right? We can verify that. Container ls, cool. All right, so now let's stand up the influx stuff. So profile equals influx, and we're gonna run the same commands. Um, this is gonna be pull. We're gonna pull influx and Fanuc-Driver. While that's pulling, let's see what, I think it's 170, and let's go to Dazzle. All right, so we got two containers, and we're gonna wait for these guys to come over. So on another machine here, I have the Fanuc simulator. It's turned on. It's in an alarm state, and we'll get back to that later in a minute. All right, so these guys are pulled. Now we're gonna create those containers. Now we're going to start those containers. And when influx starts, it's going to provision itself, basically. So if we go back and look at Dazzle, all right, we're gonna see influx is started up. And if you scroll all the way up, where is saying it, I forgot where it is, but it says in here somewhere that I don't know. I thought I saw it in here before where it said that it's initializing itself. I don't see that in this log. All right, cool. So influx is up. You can see that's data already started coming in. And if you go to Fanuc-Driver, let's go through those logs, and there's going to be a lot of them because we set it to debug. Right, so Fanuc-Driver starts up, it identifies the width of the width, you know, of the architecture that it's on, 64-bit, the arguments that it's passing in, the configuration and the nlog configuration, and then in debug you can get a lot more verbose output, right? So here it's adding every machine, right? It's adding it, but a lot of them are disabled. So something I fixed in another next release is that if, like for example, this machine is disabled, well, then really the MQTT connection and other connections should not be happening. So I fixed that. Let's go to the one that we're interested in, which is going to be the example. Where is it at? Oh, okay, yeah, here, example influx. So it's enabled. The strategy is what defines what data is going to be collected. The handler is how the data is going to be transformed before going out to the transport, which in this case is influx line protocol. Okay, so if we go down, it's initializing, creating itself. Okay, great. The strategy was started and data already started coming across. So here in debug mode, you're going to see all of the line protocol data coming over. So there's going to be a bunch of that. And then, right, nothing. So kind of initialized, got its initial values from the controller, and then nothing's happening on the controller. So every second, um, you're going to get a kind of a health check. And for example, this one, the sweep measurement, calls out if it's online and the machine is healthy. And if it's not healthy, that means that not all of it doesn't necessarily mean that there's something critically wrong. It just means that it needs to be looked at because some of the collectors might be failing depending on the controller state. And that's actually data that we should add to be sent to Influx so you can easily troubleshoot it. Um, so as you can see, the entire sweep takes here 800 milliseconds, 900 milliseconds, a second, and so on. And right here, you're going to see every minute, you're going to see the state measurement getting republished, probably because the power on minutes is incrementing, right? Here's 63. So if you keep scrolling down, we've been kind of sitting here. It's 63. Yeah, what happened here? Why did oh, 62. Okay, yeah. 63. All right, keeps going on and on and on. And let's say if we now start up the controller, actually, let's do something simple like resetting and resetting the controller and removing the alarm. If you go back to Dazzle, we'll see that messages, I think it's the messages that changed. I forgot how I have it set up. It's the messages measurement. And for example, now if we hit the e-stop, we should get a, it's somewhere in here. I'm looking for a emergency code, but I'm not. I don't know. All right. So this is interesting, right? Now it's starting to show you some of the invocations of focus that have failed. And in this case, it's the G code. It's trying to get the cutting instructions from the controller, and it can't because it could be multiple reasons. Whatever the reason code 13 is. So this is a good way to step back and look at the configuration again. And I could show you volumes. What's in here? Fanuc-Driver. Let's just cat the config. And inside the configuration, the collector section is which calls out what data to collect. So if you wanted to say if something's not supported on a specific piece of machine, we want to come in here and comment that line out. So in this case, we would comment out the G-code data line. But we'll just go with what we have. So, okay, cool. So let's start up the machine. Let's take it out of emergency and let's cycle it. All right, so it's running. And now what we should be able to do is go into 10.1.10.170 8086, and it's our default instance here, and admin password. Okay, and you can start exploring the metrics right away, right? So for example, if you want to look at the alarms, and I'm not going to get into Flux right now because I'm still kind of fresh. But if you want to look at all the alarms, right? It's pulling in all the alarms and right, so you got the measurement, the field, and the value. In another video, I'm going to go through how to actually create some relevant visualizations and post that template up to GitHub as well, so you could just import it and have the dashboards ready. Yeah, that's pretty much it. So the list of what's being sent over here is growing. Let's see, for example, if we look at the performance of Focus itself, and this is probably from the very beginning, right? So you could see, you could easily trend the performance, right? And typically it's under 1 second. It should stay under 1 second. There's the initial startup that took a little bit longer. I have some machines actually connected to over VPN, and that's obviously much longer. I mean, it could take up to 5 seconds to get all the data and come back, but it's still functional. Okay, so again, back to here, you can start at docs.ladder99.com, go down to the Fanuc focus, and scroll down to Docker to set it up. There's also instructions on how to actually build it into a executable binary and run it that way. But Docker has been so much simpler just to work with. All right, thanks for watching, guys. Give it a thumbs up and talk to you later.